Okay, so now let us look at this example. 5 cards are dealt from a shuffled deck. What is the probability that a hand contains exactly 2 aces? Given that we know it contains at least 1 ace. Okay. So when we read this sentence, given that we know it contains at least 1 aces, we know that this problem is going to be a conditional probability problem. Okay. So to start with all these type of question, let us set up the event first. Okay. So if we set event A as are going to have 2 aces exactly. Okay, that's event A. Event B are going to be that, so this hand gonna contains at least 1 aces here. So the problem, do you see that? It becomes into this, right? It becomes into this, and then based on the conditional probability, this equals to the probability of A intersect B over P of B, right? But as you take a look at those 2 events, the intersection between have exactly 2 aces intersect with at least 1 ace. Do you agree that the intersection which equals A, right? So in other words, this becomes into, okay. So right now, all we need to do is to, if we can figure out what is the probability of A and what is the probability of B, and then we're good to go. Okay. So for the probability of A, so on the bottom is we're going to have 50 chooses 5, right? Since we have exactly 2 aces, so it's going to be 4 chooses 2 times 48 chooses 3, right? So that's probability of A. Probability of B is we're looking for what is the probability it has at least 1 ace, right? So if it's at least happens, we're going to use its complement, which is 1 minus B complement here. The complement of the event B complement is going to be, there's no aces, right? So it's going to be 1 minus, it's going to be 48 chooses 5 over 52 chooses 5, right? So you got A probability of A, you got probability of B, and then you can easily to drive that, right? So in fact, you can simplify this. A given B equals to, you can let them have the same denominator, and then it's gonna be 4 chooses 2, 48 chooses 3 over 52 chooses 5 minus 48 chooses 5. Okay, so that's the first problem. Simple. Second one. Okay. Second one, it says like this. So you have a bias coin, okay, and then with the probability of having a head is P. Then you'll toss the coin 20 times, okay, and then it asks us, okay, what is the probability that you observe 8 heads and then 12 tails. So part 1, don't you agree that it's a binomial, right? It's a binomial pair sense. So basically, we're gonna have it's 20 chooses 8 times p to the power 8, and it's 1 minus p to the power of 12, right? So that's the probability here. Part 2, you observe more than 8 heads and more than 8 tails, right? So if we assume that x be the random variable stands for the number of heads, and then we let the y be the number of the tails. So one of the relationship between x and y, it's the sum of them is going to be 20, right? And then we're looking for, okay, what is the probability that x is greater than 8, right? And y is greater than 8, okay? So this, since x plus y equals 20, so y is greater than 8, we can solve y in terms of x, which is 20 minus x. If we make the substitution, you can get this is 20 minus x is greater than 8. If you solve for this inequality, that means that you're going to have x is less than 12. So in other words, the equivalent representation for y is greater than 8 is x is less than 12. So in other words, you're looking for the probability that x is greater than 8 and x, meanwhile, is less than 12. So that gives us is, right? So in this scenario, what are you going to have? X can only be 9, 10, 11, right? Can only be those. So the probability of you having 9, so it's 20 picks 9, P9, 1 minus P11 plus 20 picks 10, so it's P10, 1 minus P10, and then plus okay, so that will be the probability for this one.